Everyone, here let's see the next series uh, in the mathematical induction. Here in the last series we have seen well-formed formulas and Wagner's form. Now we are going to see mathematical induction. Mathematical induction is also known as a mathematician Gauss law. He is a German mathematician who did not pay attention in a class at the age of 8, and the teacher made him a sum of all natural numbers from 1 to 100. The story of Gauss uh, made him with the correct answer within a second. The teacher infuriated. And how does Gauss do it? Well, possibly he knew the formula 1 plus 2 plus 3 plus etc. to plus n equivalent to n into n plus 1 for all natural numbers n. Mathematical induction allows us to prove equations such as 1.5 for an arbitrary n. It also allows us to show that every natural number satisfies certain property. Suppose we have a property m, we think it is true for of all natural numbers. We write m of 5 to say that the property of 5 is true. Suppose we know the following two things about the property m. We have to prove that in base case natural number 1 has property m, that is we have to prove m of 1. And the next inductive step, if n is a natural number, then we have to assume to have a property m of n. It shows that it has a property of m of n minus 1. That is, we have to prove m of n is equivalent to m of n plus 1. These are the steps we have to follow to find a mathematical induction using Gauss law. The next one is semantics of propositional logic. What is the semantics of propositional logic? For every well-formed propositional logic formula, the number in the left brackets must be equivalent to number of right brackets. Here we have to prove that we proceed at the values of well-formed formula, that all formulas of height have the same number of left and right brackets. We assume m of k for each k less than n and try to prove m of n. It takes the formula that theta that pi of height is n. We have to prove the formula in two cases. One is the base one and the next one is inductive step. In the base case we have to prove n equal to 1, then phi is just a proportional atom. So there is no left or right brackets, it is equivalent to 0. In inductive step, if n is greater than 1, then we have to prove through parse tree for a well-formed formulas such as negation, implies, conjunction, disjunction, etc. We assume that implies in other three cases such as phi 1 implies phi 2 are some well-formed formulas which they are just a left and right respectively of two subtrees. It is clear that heights of pi 1 and pi 2 are strictly smaller than n. Using induction hypothesis, we therefore conclude that pi 1 has same number of left and right brackets, and the same is true for pi 2. But in pi 1 implies pi 2, we added just two more brackets in and 1. It implies that we have to combine the both are same. both the results are same. These are the semantics of propositional logic. We have framed. Uh, the following, the next series, the next topics can be followed in the next series. Thank you.